Safer Chemicals Podcast. Sound science on harmful chemicals. Hello and welcome to the Safer Chemicals Podcast. My name is Adam Elwan. In this episode, Peter van den Zandt, ECHA's Risk Management Director, joins us to speak about per- and polyfluoroalkyl substances, or PFAS in short. Now, these so-called forever chemicals are a family of over 4,000 synthetic chemicals that have been and continue to be widely used by society. The problem, though, is that their use has resulted in worldwide environmental pollution and human exposure. They're called forever chemicals because they resist degradation, and some can be easily transported in the environment. Others have also been shown to be harmful to our health. The EU's chemical strategy puts PFAS policy front and center. The Commission commits to phasing out all PFAS, allowing their use only where they are proven essential to society. As part of this work, ECHA proposes to restrict all PFAS used in firefighting foams. Another restriction proposal is in the making by 5 European countries that covers PFAS in any other use, including, for example, product packaging, cosmetics, and non-stick kitchenware. Today, we will be deep diving into PFAS used in firefighting foams and how the EU is preparing to restrict them. Thank you for joining us, Peter. If you could maybe just start by breaking the ice and introducing yourself.
Hello, my name is Peter van der Zandt, and I'm the Director of Risk Management in ECHA, responsible also for restrictions and authorizations under REACH.
Maybe let's start first with why PFAS are a problem and why do they need to be further controlled?
Well, first of all PFAS are very persistent in the environment. And this persistence stems from the presence of fully fluorinated carbon atoms in their structure, which have very strong chemical bonds. So typically PFAS have many of these groups in their structure and sometimes in a chain. And that's why PFAS are likely to stay in the environment for decades, centuries, and even longer. Because of this persistence, as long as the PFAS continue to be released to the environment, people, animals, and plants will be exposed to ever greater concentrations of these chemicals. The releases of PFAS and their mobility in water and air causes contamination to groundwater and drinking water, which is difficult and costly to either avoid or to clean up.
And I guess that's why the European Union has already taken action to limit the use of PFAS. Can you tell us what's being done?
Some members of the PFAS family have already been restricted in the EU, like PFOA, and for some the restrictions process is ongoing. Some PFAS are eliminated globally under the United Nations Stockholm Convention that regulates persistent organic pollutants. Because of the global and EU restrictions covering many long-chain PFAS, the PFAS currently used in firefighting foam technology are mainly short-chain PFAS.
You mentioned about the concerns a little bit already, but what about the concerns to our health?
People are exposed to PFAS through drinking water and food. All of us have PFAS in our body. Some PFAS have been shown to harm reproduction and the development of fetuses. The liver, kidneys, bones, and some other organs are affected when exposed to PFAS for a long time. Several PFAS are known to cause cancer, and some may interfere with the hormonal system.
Now, I understood that the health concerns you mentioned have been proven for these longer chain PFAS. So these are the ones made up of a chain of 6 or more carbon atoms and which have already been used for decades. But what about then the shorter chain PFAS?
There is evidence that many of these concerns also apply to shorter chain PFAS, including those still used in firefighting foams. Because of the persistency of PFAS and their health effects, it is important to prevent and to minimize as much as possible the future emissions of PFAS so that we do not increase the environmental burden anymore for the future generations.
Okay, then to firefighting foams containing PFAS. What are they used for and by whom?
PFAS-based firefighting foams are effective because of their stability at high temperatures. Firefighting foams are usually used to put out fires involving flammable liquids. The oil and the petrochemical industry is the sector that uses the PFAS-containing firefighting foams the most, but they are also used by municipal fire brigades on ships and at airports. So their main use is in the industrial setting. Also portable fire extinguishers that people may have at home or in their camper vans or in boats might have PFAS in them.
What about then the manufacturing side? I mean, what kind of numbers are we talking about? How much of this foam is being produced?
Around 30,000 tons of firefighting foams are manufactured in the EU each year by around 25 manufacturers.
And how much of the foams are still PFAS based?
60%. So around 18,000 tons of all firefighting foams is still PFAS based. Despite previous restrictions and despite industry's voluntary actions to move towards safer alternatives.
But PFAS-free foams are already being used, right?
Yes, indeed. Actually, there are already fluorine-free foams available that have been successfully used in most sectors. Around 9,000 tons are used each year. For some uses, alternatives are not yet widespread, and further testing of their performance is needed despite promising early results. And this is the case for fires in large flammable liquid storage tanks, for example.
And can you say how much PFAS ends up in the environment because of their use in firefighting foams?
It's difficult to estimate the releases of PFAS from their use in firefighting foams because fire incidents are difficult to predict, and a large fire could require the use of large amounts of foam. We have estimated that on average around 470 tons of PFAS are emitted to the environment from uses of firefighting foams each year. This means that over a period of 30 years, this could be as much as 14,000 tons of more PFAS that ends up in our environment. We know that PFAS-based firefighting foams have caused cases of environmental contamination in the EU, both of soil and of drinking water.
And as you mentioned earlier, this contamination may be irreversible and result in continuous exposure and health problems, not to mention their ability to be transported basically around the world.
Yeah, they are already found in remote areas like in the Arctic and the Antarctic, at open seas, or even in the higher atmosphere.
Now, you mentioned several cases of environmental contamination from PFAS in the EU alone. Can you give us an example?
One example is the contamination from the use of PFAS-containing firefighting foams at Düsseldorf Airport, but it's just one of many examples in Europe. There, the PFAS foams were used for training purposes over many years and contaminated the local soil and groundwater. The groundwater in turn contaminated local lakes as well as the River Rhine. Soil and groundwater in that area is being removed since 2015, and it is estimated that the entire remediation of the area will cost around 100 million euros until it's finished. The PFAS contamination from fire drills exists at many other airports and military air bases throughout Europe.
If we then go a little bit deeper into the actual restriction, what does it propose?
We have investigated the effectiveness and associated socio-economic impacts of different potential restrictions options to address the identified risks. One effective restriction option is to ban the use, placing on the market and export of all PFASs, which is around 4,700 substances, in firefighting foams with sector and use-specific transition periods. The restriction is estimated to reduce emission of PFAS in the environment by more than 13,000 tons over 30 years following its implementation. For this option that I'm referring to, the estimated cost to society is around 7 billion over 30 years. These costs include the price of modifying equipment for the use of alternative foams, the cleaning of equipment to remove residues of PFAS foams, and the price difference between PFAS and fluorine-free foams, only to name just a few examples. By banning the whole PFAS class for this use, the EU can address the risks arising from regrettable substitution, where a substance would be replaced with one that is later found to have similar hazard concerns, such as when PFOS was replaced by PFOA and PFHXS in firefighting foams in the past.
Okay, and since PFAS are used so widely in firefighting foams, and the proposal is to ban the whole PFAS class, how do we make sure not to compromise on fire safety?
Well, that's of course an important point. Firefighting foams are needed to ensure fire safety. And that's why in those sectors where alternatives are not yet available, we propose transition periods for different industry sectors and uses so that there is enough time to develop fluorine-free foams, to test them, and to adapt existing equipment to reach the same level of protection as with the PFAS-based foams.
Now, we already touched upon the universal or wider restriction of PFAS that's in the making. How does this proposal relate to that?
Yeah, there is indeed a universal restriction proposal in the making by member states, by Germany, the Netherlands, Norway, Sweden, and Denmark, that will cover PFAS in uses other than firefighting foams. They will cover the same substances, but the uses will be different. The universal restriction will be, of course, broader. We have been working together with the 5 national authorities to align the rationale of the 2 proposals, which will follow the same approach in terms of substance identities and in terms of assessment of the hazards and the risks. The firefighting foam proposal, restrictions proposal, can already be used to deal with some of the issues, mainly on the risk assessment side, that will be met by the universal PFAS restriction and will speed up the discussion on that initiative.
Could you still clarify why these 2 proposals have been done separately and not in the same package?
The simple answer is that the work on PFAS in firefighting foams started earlier. When the Commission asked us to investigate a potential restriction of PFAS in firefighting foams in 2020, there was already a study available of these foams and the alternatives that fed into this current work on the restriction proposal. So the current proposal paves the way for the wider proposal that will follow, and of course also helps to share the burden. And we are, of course, working very closely together with the other countries to ensure the consistency.
Okay, thank you. Then on to the next steps. So now that the restriction process has started from the submission of this proposal, what happens next?
Now that ECHA has done its science-based investigation, there will be a 6-month consultation on the proposal, which will start on the 23rd of March 2022. And we invite all stakeholders to send us any technical and scientific information that they might have on PFAS and firefighting foams, be it on their production and use, exposure and risks, alternatives, impacts on society, etc. We plan to have an info session to explain to stakeholders how best to contribute to this consultation. At the same time, 2 scientific committees will start assessing the proposal. One will be looking at the risk to people and the environment, and the other on social and economic impacts. These committees' opinions are expected to be finalized in 2023. The decision on the restriction will subsequently be made by the European Commission together with the EU member states.
Thank you, Peter, for giving us a snapshot of the restriction, also in the context of the wider restriction of PFAS that is coming up. Follow our news to stay up to date, and remember that you can give comments in our consultation that could be useful for us to consider for this restriction. As Peter mentioned, the consultation starts on the 23rd of March this year. Don't forget to subscribe to our podcast at echa.europa.eu/podcasts. Safer Chemicals Podcast. Sound science on harmful chemicals.